Okay, so in class on Thursday, we started to look at this worksheet, simplifying complex fractions. I gave it to you in class, and we looked at number 5, and we did it two different ways. One was the intuitive way, where you combine these two fractions in the denominator and get a single fraction, and then write it, instead of as vertical division, write it as horizontal division and do keep, change, flip. And then I showed you a second method where you could very easily get rid of all the denominators. So turn this from a complex fraction into a non-complex fraction in just like one step. So I want to do another one like that because I feel like we just, it was quick. Towards the end of class, we didn't have a whole lot of time to finish the conversation. So I want to take a look at number 6 on that same worksheet, and then have you practice number 10 on your own. All right, so I'll do 6, you'll do 10. All right, so again, if you remember, in the intuitive way, we would add these two together to get a single fraction and then divide using keep, change, flip. But in the second method, the faster, less intuitive method, we would take and find the least common denominator of all denominators. Now, these two denominators are obviously present. All right, this one doesn't look like it has a denominator, so I'm just going to rewrite it as x minus 1 over 1 as x minus 1 over 9 plus 9 over x minus 1. So now we can see the denominator of all three of the fractions right here, and we need to find the LCD of all three of them. Right, so our LCD is going to have to contain a 9 so that this is happy, and it's going to have to contain an x minus 1 so that this guy is happy, and it automatically any denominator contains a 1, so we don't really need to add anything. So our LCD is 9 times the quantity x minus 1. Don't multiply that out, just leave it as it is because it's going to make the canceling in the next step a lot easier. All right, so what we're going to do is we're going to take our x minus 1 over 1, divide it by x minus 1 over 9, plus 9 over x minus 1, and we're going to multiply top and bottom by the LCD. So again, we need to make sure that the 9 x minus 1 gets multiplied in the top, and the 9 times x minus 1 gets multiplied in the denominator. And again, as I said in class, for some reason it's just visually easier if everything is fractions like that. Right, so just so that you can see these are all the numerators, these are all the denominators. If you don't do that, sometimes it's confusing because then it looks right in the center of the other fractions. All right, now what we're going to do is we're going to multiply these two fractions together, canceling out anything up here in the LCD that's in common with this one. Now this one's a little bit dumb because these are both 1s. There's nothing that's going to cancel out. So when we multiply across here, this is going to become 9 x minus 1 from this times another x minus 1. I'm going to write it that way, but you could just write it 9 times the quantity x minus 1 squared. I'm going to choose not to add that 1 in the denominator right there because I'm just going to say, well, the 1 here canceled out with an implied 1 in here, so we'll just leave it like that. And then in the denominator, this is a little bit more steps to it because we have to distribute that 9 times x minus 1 once to this fraction and once to this fraction. So when we do these two right here, we notice that this 9 up here is going to cancel with this 9 right here. Again, that should always happen. All denominators should cancel because I made sure that they were included as part of the LCD. So this and this will cancel. So all that's left is an x minus 1 times x minus 1. Right, this is going to cancel out. I'm not going to draw it canceled because I want to make sure that you remember that it also applies to this one. Okay, now when I distribute this fraction to this one right here, this x minus 1 and this x minus 1 will cancel. So all that's going to be left is plus 81. All right, so in that one step, we cleared out all the parts that made it a complex fraction and just got down to this. Now, I am sure that somebody's going to want to try and cancel these two out with these two right here, but you may not because of this plus sign down here. This is a term and this is a term. You may not ever cancel out terms, only factors. So if this had been 81 times x minus 1 times x minus 1, cancel away, but because that plus, it's two separate terms and you can't cancel out terms, only factors. So then I'm going to multiply out the top, because what we'll see is after we expand this, is there any way that we can cancel some things out? In fact, I'm not going to do that. I'm going to do that to the bottom, but not the top. This is already completely factored. I'll just write it in that version. Down here, when we do x minus 1 times x minus 1, I'm going to kind of do this as an aside. I get x squared minus 2x plus 1 plus that 81. I'll combine like terms, so I get x squared minus 2x plus 82. All right, so really what we would need to see, is there any way that this will factor so that it can cancel out with this? Again, it's possible that this is going to factor into two terms. I'm looking for two things. Actually, no, it's not. It would say I'm looking for two things that multiply to 82 that add to 2. That's impossible. And so if this had been subtract, maybe that would be possible. But with its adding two things that multiply to 82 that add to 2, it's not going to happen. So this cannot be factored. So we're going to have in the denominator x squared minus 2x plus 82. And that is the final answer. All right, so what I want you to do is I want you to go ahead and stop the video and do this problem. And then when you're done, come back and I will work through it and you can check to see if you got it right. All right, so turn it off. Okay, welcome back. I hope everything went well. So again, we're going to look for the LCD of all the denominators. So we have an x plus 1, an x plus 1, a 3x, and an x squared. So the LCD of this fraction, of this complex fraction right here, or of all the fractions in the complex fraction, we need to include an x plus 1 because of this. This guy is now happy. Right, we need to include a 3x for this, and we need to include an x squared. I'm not going to put another x squared because I already have a single x, so I'm just going to change this to an x squared. Right? And again, what does it mean to be the least common denominator or the least common multiple? It's the smallest thing that everything will go into. Not all at once, but one at a time. So x plus 1 will go into this, x plus 1 will go into this, 3x will go into this. There's an extra, extra factors, but it'll go in, and x squared will go in. Right, so that's the least common denominator or the least common multiple of these four denominators. So then I'm going to take and multiply top and bottom by this. I'm just going to rewrite this with the 3x squared out front. So this is going to be 3x squared times x plus 1 over 1. Again, you don't have to do that step right there of putting it over 1. I just like to see all three things as fractions. And then we've got 3x squared times x plus 1 over 1. And I'm going to distribute this fraction into this parenthesis, so both terms get this. And as each term gets it, it cancels out a different amount. So for example here, this 3x will cancel out with a 3x in this 3x squared. So this is going to be gone. All that's left from this is going to be one of the x's and an x plus 1 times that 4. So we're going to get 4, the remaining x, and then the x plus 1. All right, now when I go through and I cancel out this x squared, that's only going to cancel out with this x squared, so this will be gone. But I'll still have a 3, so the 2 times the 3 will give me the x. I'm sorry, the 6. The x squared's canceled out, so they're not there. But there is an x plus 1 left. Right, now we do the denominator. So I'm going to multiply it by each term in the parentheses here. This x plus 1 is going to cancel out with this x plus 1. So all that's going to be left after that's gone is this x and this 3x squared. So it's going to be 3x cubed. And then we'll do the same thing here. This x plus 1 is going to cancel out with this x plus 1. Again, don't say, oh, I already used up that x plus 1 to cancel it. When we distribute it, each thing gets that whole quantity right there. So this one doesn't get whatever's left over after we cancel that one out. It gets a brand new version of it. So the x plus 1 will cancel out. So all that's going to be left is the 3x squared times that 4. So it's going to be minus 12x squared. All right, so then you distribute that through, you get 4x squared plus 4x. Distribute this through, you get 6x plus 6. In the denominator, you've got 3x cubed minus 12x squared. Okay, I'm going to combine like terms up here. There's nothing that will combine with the 4x squared, but I can make this a 10x and a plus 6. So let me come over here and write it. Sorry, I'm banging into stuff on my desk as I'm trying to do this. All right, so this is going to simplify to 4x squared plus 10x plus 6. Again, you might be thinking, well, why didn't you multiply this out? But now you are. And again, the difference is this was a single term in this problem right here. It was completely factored already. In this right here, this is two separate terms. So if I'm going to be able to put this into factors, I have to multiply it out first, get it all down as a single polynomial right here, and then try to factor that. All right, in the denominator, I've got 3x cubed minus 12x squared. Right, I see that each of these have a 2, so I'm going to write that as 2 times 2x squared plus 10x, nope, plus 5x plus 3. And then in the denominator, I can take out a 3x squared. And this is going to leave x minus 4. All right, so this I don't believe is going to factor. Again, it's a harder trinomial, so we're looking for two things that multiply to 6 that add to 5. Actually, this will work. I still don't think it's going to make a difference because it's not going to cancel with the x minus 4. The two things that multiply to 6 that add to 5 are 3 and 2. And just as a shortcut, I'm just going to write what the factorization is just because I'm almost out of space. It should be 2x plus 3 and x plus 2. Nope. That's not it. Sorry, x plus 1. X plus 1. I don't know why I said that. That should do it. And then we've got 3x squared times x minus 4. Unfortunately, nothing cancels out. So that's it right here. If you stopped at this point, I'd say, yay, that's pretty good. If you stopped here, I'd say that's okay. But again, we want to make sure that whoever's looking at our work doesn't wonder if we just forgot to factor and cancel out or didn't know how to factor it and cancel out. Here we can show them for sure we tried our hardest and it didn't work. So any one of these three would be okay, but I would say best, better, good. Okay. Hopefully you did all right. Let me know if you have any questions. All right, bye.